is the flexibility of this. So it's possible to, with these external files, certainly I'll give you an example from Unity, there is a folder in there where it essentially streams it in so it's separate to the compiled executable, meaning you can tweak the values without recompiling the whole game. So it kind of aids that game balancing and testing, which is done by other people, without having to go through like compile times. That can be one advantage of this sort of approach.
Now, in the case of how we're going to do things with data tables, because we're actually loading it in and populating it in the editor, it will be compiled. So that's just something to watch out for the way that we're doing it today. But just to give you an idea on how data tables work, you can think of a data table ultimately as more or less a spreadsheet of different values, but those values can be, it can be a float, it can be a string, it could be a vector, or it could be a linear color, for example, like we've got here. This data table, we've got two enemies for this week. We have our base enemy, which should look fairly similar. Its scale is 1, its health is 100, it moves at 600, which is the default speed, and we've got just a random color here for it as well. The one underneath it, large, this is actually a bigger enemy. And I might actually adjust it so that it's 3 times scale, but we'll do that later. What we're doing here is we're actually putting all the values. We could add as many of these as we wanted to in here. And all we need to do, once we're happy with this, is just file, download a CSV. So this is really useful if you're working in a team with designers, where you set up your classes, which we're going to do, and then you basically just say, all right, cool, here are the values, the different columns of information, fill it out as you see fit, and you can modify it on the fly as well. Again, you can modify it in engine. It's only a thing you will need to rebuild it if you want to make changes for the end user. As long as you're in editor, you can just change it, hit enter, and then hit play, and it'll work fine. You'll notice that enemy scale and enemy color are kind of set up differently with the brackets. These are just in a format that Unreal recognizes as a vector and as a linear color. If you're ever unsure, what you can do is create a data table in Unreal, fill out the data, and you can right-click, copy, and then just paste it into a file, and it'll give you the full row of data. So if you're ever unsure, you can just do that. In fact, I will tell you now, I did that for this because I wasn't sure how it was going to represent scale or color, because it had been about 3 years since I've dealt with this. All right, so like I said, let me just adjust this to 3, 3, and 3 to make it a bit bigger. I'm going to do File, Download as CSV, or comma separated values. And it will save into, I've just got it in downloads. What I'm actually going to do is I'm going to copy this into my content folder. Now this doesn't mean it will be shown inside of Unreal, but I'll explain the reason why I do this when we get to it. There we go, it has it detected. Let's just go, don't import for now. We don't really care too much. And I'll just close down Vivaldi so I actually have enough RAM to do what we need to do. Alright, so first things first, before we jump into any code, we did mention that we have an enemy color. We could create a custom master material for the enemies, but as it turns out, the current one that Unreal has set up for us actually has a tint available. So what we're going to do instead is we are going to adjust the current material instance, enable a setting basically, and then set it in code. So if I go to my, my enemy character here, so I'll just open this up here. You'll notice on the right-hand side, we have a skeletal mesh, which is SKM Mani Simple. And underneath this, we have two materials, element 0 and element 1. Now, some meshes will have just one material, some will have two. And in this case, they're actually named slots. Now, it might be a bit tricky to see unless you're up closer to one of the screens, but the top one is M_head legs, and the bottom one is M_torso. So these represent the different parts of the mesh. what we're going to do here is we're going to modify the torso so that it is able to have color. If I double click here, this will actually open up the material instance. And inside a material instance, you'll also notice the parent over here, and it's actually parented to the head legs, but we can make changes here that will only apply to the torso. And if you're curious, by going through another layer, this is actually what the master material for the mannequin looks like. Now, there's a lot of stuff here, but it isn't actually as complex as you might think, especially considering they comment about a bunch of stuff. So like this comment over here is just on the emissive for the logo. You've got some masking happening. You've got some camera positions if you're actually at the head, normal maps, and similar to what we had previously with metallic, roughness, ambient occlusion, base color. The important part that I want you to pay attention to today is if we look at base color, you'll notice right here, there is a parameter called paint tint. We don't need to create a new material. All we need to do in code is adjust this parameter and it will update for us. Nope. Now, the key thing to keep in mind is when you've got parameters, you'll notice that you've got a bunch of things enabled or disabled. If it is ticked, you are overriding it. If it is unticked, then you're leaving it as the base. We just want to make sure that we are ticking that we are going to override the paint tint. So I'm just going to make sure that that is the case. I'm not going to change the color for now. We're going to do that from code. But by making sure that that is ticked, it means that we can actually update that value and it will know to check it. Cool. So for our data table, there are two parts that we need to create. The first part is actually going to represent an individual row in the data table. For this, I'm going to jump into Writer, and I'm actually going to create a new struct from Writer. So I'm not doing this from Unreal, I'm going to do this from Writer, and I'm going to build it up myself. It is very uncommon that you will do this, and I generally recommend avoiding doing this for any sort of classes, but for structs, it is okay because it's fairly straightforward to get them up and running. Mike, did you want to mention structs?
Well, I was curious, has anyone here come across structs in your, couple of hands in your programming adventures? I think this is the first time we've used one this semester. Those unfamiliar with it, the way I think of a struct, well, first of all, I think of it as a structure. It's a structure of data. It's a little bundle of data, a collection of data. It's like a really cut down class that doesn't do anything. It just stores stuff. So, I mean, some languages you can put functions in them, which gets confusing, but in this, we're just having data in this structure. We can pass it around. We can treat it as its own data type, kind of like a class. And back in the C days before the ++ came along, all we had was structs before object-oriented code. So these are really useful, as you'll see in this demo.
Yep, so I'm just going to right click on any file, it doesn't actually matter. I'm going to add class/struct, and I'm going to select struct. And the name I'm going to give it, the name is important, F enemy info. Now, if you're curious about the F, this is a prefix that we use in Unreal for structs. And I'm just going to hit enter, and this is just going to create, as you can see, this is just a base struct. This isn't even an Unreal struct yet. Just making sure this is picking up perfect. So there's a couple different things that we're going to do here, and this is actually going to look a little bit weird because we're doing things that we've never done before, but we'll just highlight why. The first part is we're going to do an include for engine/data table. We're going to need this because we are going to inherit from a class inside of this header. The part that you haven't seen us do before is actually manually doing an include for f enemy info.generated.h. Now, the interesting part is this file doesn't exist yet. This is something that the editor will create for us. And in fact, the way that we get the editor to do this is the next two lines of code that I'm going to add. uStruct, and I'll make this a blueprint type, and all this means is that we can edit it from blueprints, and I'm going to add generated body. So if you've ever wondered what generated body does, this This is an Unreal macro that actually creates this file. Now, I also need to have this inherit, so structs can still have inheritance like classes. I'm going to do public f table row base. So this is just a, again, it's a struct inside of the data table header file that specifies how a particular row inside of a data table works. And then all I need to do from here is just specify the variables that we're going to have, or the properties. So I'll do uProperty, edit, anywhere, blueprint, read, write, and I will just, as always, copy that so I don't have to keep typing it out. We want an F vector for enemy scale. We want a float for enemy max health. We want another float for enemy max speed. And then we also want an F linear color, keeping in mind American spelling for the actual variable, enemy color. Like so. And this is all we need to do. We don't need to put public or anything like that, because with a struct, by default, everything is public. So that is just how things are handled. With a class, everything by default is private. With a struct, everything by default is public. And all I need to do at this point is I just come into Unreal and I hit compile. So because I've added in that include of the .generated and I've added generated body, Unreal is smart enough to realize that even though I haven't created it inside the editor, it still needs to treat this like it would any other Unreal class or struct, and it will compile it accordingly. Technically, you can do this for classes as well, although I generally don't recommend it because, again, the compiler can get a bit funky sometimes. And also that's where you can potentially run into issues where stuff just won't appear inside of the content browser. For the struct, structs typically don't appear in the content browser nicely anyway, so it doesn't matter too much. But for classes, I'd recommend just doing it through the standard approach inside of the editor. While we're on laptop. Cool. All right, so it compiled successfully. That's all good. What I'm going to do now is I'm going to right-click inside the content browser and I'm going to create what's known as a new data table. And you can see it's this one here, and I'm going to call it, well, before I call it, it asks me to pick a row structure. So like I said, this is kind of like a spreadsheet. And what it needs to know to begin with is what a row of this data table is going to look like. And if I click the drop down, enemy info is right there. So this is why we set up that struct, because when I hit OK, I'm going to call it dt underscore enemy info. And when I open it, you'll actually notice that it has set up the rows automatically for us. There's nothing in here yet, but you can see that each of the columns is set up to be those different values that we've created. Now, what I can do is I can just click add here and I can just create a new row if I really want to. And you'll notice in the bottom, when I've got a row selected, I can change these values, and this will actually set the values in that row. However, the really powerful thing is this re-import button. If I click this, and if I go to, where was it? We put it inside of content, and I select this CSV file and click open. So it'll say here, cannot find column for enemy speed in enemy info. It expected enemy max speed. So let me just click OK. So this enemy max speed is not found. Let's just quickly have a look at the CSV file. And we're expecting enemy speed. I did this yesterday, except I thought that I had done it the wrong way around, but no. This is fine. This is a quick, easy fix. I just need to change the name of this variable. But this is actually really important because it's case sensitive. And really, what I should do and what you should do if you're in a bigger project is just have a separate file, a separate header file that just defines all of these as constants. It's the same back when we were dealing with the inventory manager in week 1. If you named the name of the icon wrong, it just crashed. It's because these sorts of values are case sensitive.
Yep, and that gave us a nice opportunity too, just to have a peek inside that CSV file. If you've never seen one, you can see that the raw data is in there. It's an ASCII file. We can just read it in Notepad, but every cell is split with a comma. And worth pointing out too that, and this is something Google Docs does, or Google Sheets does very nicely, the way you'll notice that we have commas in our data anyway with color and scale, and sometimes you just got to be mindful, like, are those commas going to interfere with the CSV itself? In this case, no. I think it's wrapped it in strings, has it, Josh? It's hard to see.
Yeah, so it's just wrapped. So, for example, here, this entire section is wrapped in a string, so that the commas inside it will be ignored. Likewise for the linear color over here.
Yeah, that's really nice. Sometimes other programs might have an option embedded in them to like escape certain characters, where it puts like a slash in front of it, which means that this character needs to be treated as content, not as like structure or syntax of the file too.
And also, if you ever see me open CSV files in a text file and you think it looks gross, it's because I don't have Excel installed on this machine, is the short answer. And if I jump back to enemy info now, let me just close that down actually. Save, hit compile. Should be happy enough. Cool. Reopen the data table. And it is going to be annoying, is it?
There's also a Google Sheets supports a TSV file, which is tab separated value.
Yep.
I've used that before. Once I was dealing with a lot of data, it was full of commas and like it wasn't escaping them properly. There was so many in there. Something weird was going on. It was breaking the data.
Yep.
So TSV, I swapped to in that case.
Yeah, and in this case, because I had did this before I actually set up the data table, it's not changing nicely, so I can just recreate it because it's super simple just to do DT underscore enemy info a second time. Perfect, there we go. Enemy speed. Now it's working the way that we want it to. And if I hit re-import, I select the file again. Voila. You'll actually notice this time it has picked up enemy speed and it has set it correctly because it was able to recognize the columns. Now, the really neat part about this is that if we have a look in the data table details, you'll notice file path, it actually has the source path for this file. So when it asked me then if I wanted to like select a file, once I've done this once, if I just say, actually, I don't want this to be 150, I want it to be 100, and let's say you edit a bunch of different rows, just click re-import and it'll just do it automatically and it'll pull everything back in. So it doesn't need to link the file another time. So this is the really nice thing about data tables and data rows. Now, at this point, we're going to make some code modifications so that we can actually, utilize it inside of our C++. We need to make two modifications here. The first one is inside enemy, because at the moment, the enemy doesn't actually know how to change its color for its materials. So we'll do that first, because that's the quicker of the two. And then next, we will update the enemy spawner so that the enemy spawner loads in a data table and then uses those values to generate an enemy when it spawns. Okay, so inside of the enemy character, I'm going to add a new property, which will be another U property, and this will be blueprint read write, and this is going to be U material instance dynamic pointer enemy material. Now, the reason why we say material instance dynamic is because by default, when you set a material in blueprints, as an optimization thing, it will just be static and you can't change it from code. If you ever want to change a material from code, you actually have to specify it as a dynamic instance. So we're going to create it and then set it. But the other thing that we need to do is we actually need a function called setColor. So it'll get a linear color, and we'll call this new color. Oh, nope, don't do that. Didn't even know I could do the omega sign, that's cool. I'm just going to generate the definition. Now, you'll notice there I didn't right-click and do generate. If you're curious, it is option spacebar to bring that context up. which if I remember correctly in Windows is Alt spacebar, I think. It's either that or Control spacebar, it's one of the two. Again, these are the sorts of the things that you'll just pick up the more that you work with Unreal. Okay. So, it's a bit like that today. Cool. So, inside of our begin play, this is where we're going to set up that material instance. So, first things first, if not material, what is it? Enemy material. So, if it does not currently exist, we're going to set it up. And the way that we do this is we just do enemy material is equal to u material instance dynamic : create, and we specify the parent material, and this is get mesh, so it's on our mesh, and then we do get material 1. Now the reason why we do 1 here is because when you do get material, keep in mind that a mesh can have 1 or more materials. So if we were doing it for the head and the legs, we would do get material 0. We're doing the body, we know that that's the second index, and the second index, because we start at 0, it's 1. And then the other thing that we need to do is we just need to tell it this is the current context. So this will get us a new dynamic material instance, and then once we set it back to the enemy mesh, any changes we make in code to change the color will be immediately applied to the mesh in-game. And all we're going to do here as well is get mesh, set material, and then from memory we do the index, which is going to be 1, enemy material. So we actually create it and then we set it back, overwriting the static one. If we didn't do this, it wouldn't actually do anything, because we just have a dynamic material that is just sitting inside of our class, but it's not attached to anything. This makes sure it's attached to our mesh. And all we need to do now is, inside of our new function, if enemy material, so if it exists, because we don't want to do this if it doesn't, enemy material set vector parameter value, and we know that the parameter is called paint tint, and again this is case sensitive, and it is also just, again, it has to match perfectly. A constant might be better, but in this case I'm just going to do it directly. New color. So this will then set that into the enemy material that can then be reused. And that's all we need to do in enemy character. The rest of the code is going to go inside of our spawner. Is there anything you wanted to add to this one, Mike, that you can think of?
I'll just point out, yesterday we had a good brief chat about, you just alluded to it, having constants for these names. So some people have like a header file of constants for their project. So you eliminate the chance of a typo. So it's kind of like last week, passing parameters into Niagara, passing, setting material parameters. The binding between all these systems is loose. It's just strings. So yes, a good way to get around that is having like a header file of constants somewhere in your project that can be referenced everywhere. You type them in once then, and of course need to make sure it matches on the other end too. But on the code side, it eliminates the chance of error.
Now, don't quote me on this. I am 90% sure that if you have an incorrect text file when you're setting a parameter value, it will just fail, it won't crash. 90%. It's been a while since I've done it, but I'm fairly certain Unreal is smart enough to just go, this doesn't exist, and then ignore it.
Yeah, Unity and Godot, I would assume Unreal is, yeah, just like you say, Josh. I know Unity and Godot will just ignore it.
Yeah, it's just, so we don't know what this is, whatever.
Yeah.
But that's not always the case, so you do need to be careful. Alright, so we're inside of our enemy spawner. We actually only need 2 new variables, and we don't even need any new functions. First one, uProperty, because of course we always need our uProperties, but it's because we are actually going to set this from the Blueprint subclass. uDataTable. Pointer, enemy, data-table. And then what we're also going to do is we are going to create a T array of F enemy info pointers. Oops. Where'd you... No. Oop, nope, don't do that. enemy info pointer, and we're going to call this enemy info templates. So we're actually going to pull the data straight out of the data table, although this is technically an optional step. It's just because of the kind of the way that we're doing it. If you're doing it in a more sensible way where you're doing some random variation, or you're being selective in how you actually pick which enemy, you can just leave it in the data table, because technically the rows all have a name attached to them, and you can just, hey, get me the row with this name. But we're actually throwing out the row names for what we want to do. Cool. All right, so inside of begin play, I'm just going to create a new line here. And this is going to be if enemy data table. So if the data table exists, or if it exists, enemy data table, get all rows. We need to give it a text, and I'm just going to call it enemy DT. And then we give it enemy info templates, like so, and we pass this in a reference. So we give it the array that we've just created, and it will give us back a populated array. The text, that context string, this is used inside of, if there's any errors, it'll print it to the error log. So just consider that as something just for error handling. We don't really need to worry about it too much. Now, the rest of the magic is going to happen inside of our spawn enemy. And I'm actually just going to put it in around line 43, in between the spawn parameters and where we're currently getting the actor location. We're going to set some default values. So these will be our sensible defaults if there is nothing to load from file. And we do this just because, for whatever reason, if we forget to load the data table, or if something is wrong with the way the data is formatted, we still have a sensible spawning point instead of crashing. So we've got run speed equals, I'm going to set this to 50 so that it's very noticeable if we fail. If linear color is, we want this to be enemy color, is equal to F linear color black. We want float enemy health to be, I'm just going to make it 1. Again, we don't ever want these enemies to spawn like this. This is just in case things fail. And then we'll do if F vector spawn scale, and I'm just going to give it the value of 111. Like so. So these are our sensible defaults. If the following code fails to work, at least we know that we can spawn an enemy with this information. Now, first things first, if enemy info template is not empty, so that's why we've got the exclamation mark there. If it has any data in it at all, even if it's just one row, we're going to do int rand num is equal to fmath rand range, and we're going to do 1 to 10. So get us a random number between 1 to 10. We're also going to just quickly do our pointer and go selected row. And we're going to give it a value to begin with. So this is enemy info templates, index 0. Again, we can do this because we know that at least one of them exists. The next part of code is where we're being a bit naughty and we're not doing error handling, so we need to be careful about this. If rand num is greater than or equal to 7, so in 30% of the time, basically, selected row equals enemy info templates 1. So in this case, I'm going 30% of the time, get the second row. Now again, this is only going to work because we have 2 rows. If you have more than that, you would want to set up a more intelligent way of actually doing this. You might do between 1 and 100, and then you might have some of them set up proportionally, so like 1 to 10 for one, 20 to 40 for another, something like that. Or if you wanted to, you could actually have a separate CSV or data table for each level. Maybe you have a collection of row names, and those row names are your enemies. So you can spawn in this enemy, then this one, then this one, then this one. And that's probably the more sensible way of doing it if you're actually setting it up in a proper game.
Yeah, it's kind of a picky battle. So given we're authoring this data, in this case, we can kind of pretty much get away with that. As soon as somebody else gets their hands on that spreadsheet,
we can't assume it anymore.
got to be more defensive with our code. But
Yep.
I mean, we've been somewhat defensive, having the sensible defaults if there is no data. And yeah, it's kind of a picky battles for this prototype. You know, we're authoring the data. We know there's a second row, but yeah, just as long as we're aware, as soon as someone else gets that, it's not safe.
And what we're doing here is we're just getting each of those values from this particular selected row. So run speed, spawn scale, enemy health equals enemy health. And then finally, the color, like so. Awesome. So this will then grab all those values, and again, if we have the default, it'll set them here. Now, the final part that we need to do is we're actually going to make a change to this line here where we spawn in the actor. At the moment, we are spawning it, we're giving it the position and the rotator. There is no option to give it position, rotation, and scale as separate values. The only way that we can give them all three at the same time is by using a different class, or struct in this case, because it's got F before it, which is a transform. A transform is a combination of all three: position, rotation, and scale. So I'm going to do F transform, and I'm going to call this spawn transform, like so. Spawn, transform, set location, and this will be our get actor location. Spawn transform dot set rotation is going to be our F rotator : 0 rotator. No, not is nearly 0. We do want it to be 0. Thank you. It'll give us an error because it needs a quaternion. It does not need a rotator. Thankfully, we can be lazy and just do quaternion. If you're wondering what a quaternion is, we did use them very briefly back in the maths week. They are a way of handling rotations using a fourth dimensional point in space. If that sounds weird, it's because they are weird. TLDR, they are used to make sure that if we are moving from one rotation to another, we do it in a smooth manner without any weird animation quirks. That's as much as you need to know for this unit.
The nice thing about these engines is they will express rotations in the editor as Euler angles, so your rotation around X, Y, and Z, because we humans like that, it kind of makes sense. But under the hood, the maths prefers quaternions, so it kind of gives each end the data format it wants and does the kind of conversion for us, which is nice. So we just see the Euler angles, but under the hood, it's doing all the operations on the quaternions, which, as Josh says, is safer.
Yep. Now, again, I mentioned that we're going to change this, so we actually get rid of both of the rotator and the spawn location, and all we do is we just do ampersand spawn transform instead, and that's it. So instead of having them separately, we pass it in together. Now, this will set up our the actors. Why am I blanking? This will actually spawn it with the scale. We still need to set up the other values for it. So current health, max health, color, run speed. To do this, with any sort of spawn actor function, it will return a pointer to the actor that it spawned. So what I can do here is I can just go a enemy character pointer new or spawned enemy equals cast a enemy character, and then encapsulate this in brackets. So I'll just put this across two lines to make it easier to see. So we're going to get the pointer here. The beauty of this as well is that it will spawn regardless, even if it fails to create the pointer. So just in case we need to, I'm going to do if spawned enemy, so if it exists, then we can go spawned enemy, and we can do, max health, or current health rather. Current health is equal to enemy health. spawned enemy max health is equal to enemy health. Spawned enemy, and to get its to get and change its speed, we do get character movement max walk speed, and we set that to run speed. And then for the color, all we do is we do spawned enemy set color, and we pass in the enemy color, like so. And again, we just encapsulate this just in case. It should almost, or it should never fail, but again, just to be on the safe side. You will be surprised about how users will break your code when you actually put games out there. You'll notice games these days in particular, they'll be buggy when they come out. It's not from lack of testing, it's just because when you throw, let's say, 50 people at it that are testing versus 1 million people when it launches, they're going to find things that you couldn't. Now, I'm just going to compile this, but before I jump into anything, I'll actually need to go into the spawner and tell it about the data table, otherwise it won't do anything. But we'll wait for this to compile. It's happy. So if I open enemy spawner and I go enemy data table is this DT enemy info, save, compile, and I'll just make sure it's actually on the one in the world as well, which it is, it defaulted, excellent. So if I jump in here, I'm just going to create a bunch of these, but if we watch a spawn in, that's a regular enemy. It's regular enemy again. Regular one again. I really hope it actually does randomly, probably. There we go. And one that is very much not a regular enemy, as you can tell by both the colour and also the fact that it is enormous. Also, funnily enough, you'll notice the enemy behind it is just slow walking. That is actually because we haven't got the path thing set up more complex. So it's basically going, there's something in front of me that I can't run through, so I'm going to go at the same speed. If we were to set up the pathfinding and make it a bit more dynamic, it would fix that issue. But now we have multiple different enemy types. And with that, we're done for this week. Only 2 minutes over, so we're not too bad. I'll stop the recording.